Okay, so I've been holding out a long time for some debate, some engineer to come on live chat with me. So again, I'll give away another one of the ones I would have given away had someone accepted my challenge. I've talked about this. I've shown it numerous ways in my Columbo move. I talk about the jealous wall. I talk about it repeatedly. Now, I'll give away this section here. First off, zooming in here, we see this is the column KL. There's L. K line is here. We'll call it K line. And here is the one underneath the planter box that goes to the wall. This is the gate, the fence, the railing that fits on top of that wall. Here's the railing over here. I'll let you see it in a second, giving you little clues as I'm saying it now still. So here is K. Where'd you go, K? So K is here. K. I'm looking back here in the background, somewhere about here. It's below that. There's my other K sticking up. Where are you, little darling? Oh, right here. There's the other K. Right there. There's the K. So that's where the beam went across BMA. This fracture here could be from a car deflecting. But let's talk about this. Look, I've given you many clues, and then hopefully the process. Appears the planter box and the shrubbery went down together. Planter box and shrubbery went down together. I would include that all the way back to there. So here, all the way back to K. Let's call it K91. Okay, let's do it. Let's do the reveal. Slowly. Oh, what do we have here? I'll write over it and then I'll erase it. We have shrubbery on the other side of this planter box. This planter box here, the part of the planter box, is tagged along for a while. And this part of the deck went down. The planter base box went down. This stayed up top for a moment before it had a moment that caused it to rotate like that, and I believe slide down into the bushes. So let's clear that and let's start again. So this was up here. That's the height of it. We probably put it down here, maybe even just a little bit below it. And then, as the deck went down, this did its row sliding off of here and landing on top of the shrubs here, on top of. So that tells you that there was not, and that would have not been a loud bang, would it? Because it's landing on the shrubbery. It's slowly set itself onto the shrubbery. So this gives you some more forensic analysis of what's going on in that back wall. What's going on with the back wall. As you look here, I'll do one more reveal for you. Right here, there's a gap. If you look at the underneath the deck, from the deck view, and you look down by the fireman and the dog, you'll see the gap there. That gap corresponds with the fracture that goes across and over to that guy there. So across this column here, when I say across, I mean in a deck, this is deflected and across. That's the clue about this being deflected right here. Oops. Like that. There we go. So that's part of the clue, is this being deflected on the deck. Part of the deflection has a path that leads over to there. All right, now I talked about you can't see these, you can't inspect the top of these heads, these shear heads here. You can't inspect them because they're covered in planter box material. Let's see if I can show this one. I can't. There's another image where I can show you the other side of this box. It's not in this one. Okay. So I want you to note that let's go there. Hold on. That this side of the box was also connected to this side over here. So part of my jealous wall is that how it held on and had its moment and then release. That fracture we see on the jealous wall on the back side of it is because of this moment here. This coming down this direction, and this one going that direction, this side of the box being parted in the planter box by the column. And that's why I show you the True Bricks video previously, showing you the one brick on this side and the one brick on that side. And now I'd like you to think of, consider this brick A side, brick B side, and there's your parting there, connecting to the wall over here, back here at the property, at the walkway. I'll give away also that the elevation changes, and per the survey, does not reflect that water would roll into the structure. Yes, it is. So here's let's do this. So you've got that wall, my jealous wall. Let's call that the jealous wall. And let's just call this a 9. And let's call this a 9.5, and then call this an 8.5. And let's just say these are elevation changes. Well, it is true, not the numbers, but it's close. But the elevation, the water, the raindrops keep falling on my deck, on the outside of the structure, and the street side where they closed it off and made it a walkway. That water will flow towards the front of the, north side of the structure to the street, out. Now, there's a 9 there, I stated, right? But over here it is like a 9.25. So this puts this side higher than this side. So water would flow there, but it wouldn't flow just across. It has no choice but to flow downhill still. So even though this is lower over here, it doesn't go that direction because it's lower this direction. So unless you're getting flooding, it's going this direction, and it would have to flood all the way up the hill because they, I'm exaggerating, but say this is the pool up here, and down here is the, and not exaggerating by too much because there's like a 2 foot, I think it's 2 foot elevation change. Maybe I'm wrong on that, but I forget. I wanted to do a video for that to show you that, including the deck profile. The deck profile is an interesting little beast using a survey because I'm just going to do this. Here's the pool, and this is where our concern is, right? This direction. Inside the planter box area over here, you know what? I'll just tell you this: all the low spots of the deck, they direct towards a drainage system, with the exception of, where I'm looking at right here in the background, where they have these bump outs and where the trash can is. Well, there's no drain there, so water does have to pool a little bit to work its way around and ultimately over to here inside this parking garage for the low one spot here. Some of them are out here and here. And as we found in some rainy days there, you can see some pooling. But the water does flow towards, the elevation shows that water does flow towards drains. Now people talk about the pavers and the sand, etc. Well, pavers butting together, in general, about 95% permeable. They've got a non-permeable. They've got a high rate of water rejection, especially with the PSI that pavers are made of. A lot of PSIs, a lot of pavers are made in excess of 8 to 10K, 1,000 PSI. So they're pretty resistant to water penetration, more so than a concrete deck of 4,000 PSI. They do have a waterproofing product that you can add to a water-resistant product you can add to a mix. Incidentally, that was part of the challenge in a video. They did specify a type of mix in the structure. I'll leave that for you guys to find. The other people that wish to try to find that, I have found it. So looking at here we go, at your deck here, you can see your plane is pretty sharp there. Your reinforcement is bent over there. It had probably reinforcement going across like that, steel, and when the steel slid off, it stripped this material. Let's see, I'm going to do a few of them. It stripped it, and let's see, watch this. I'm going to get this wrong. Hold on. Oh. And it's this reaction here is pretty much in plain. I'm going to save that for another time. You can see that's pretty plumb in line with this column here, this being the same. It's pretty plumb, so we don't have the column like that, and then this thing, I'm exaggerating the box, the outer part of this box like that. We don't have it like that. Let's see, clear, and back again, and zooming in. Oops. So we have that box looking like this, like a 90. These are thereabouts parallel also. This is the one that's not, well, because it was anchored in the wall, and it couldn't maintain equilibrium, a balance up there on top of the wall where it was at one point when the structure went down, and it made a choice, when the deck fell down in frequency and vibration, it went this direction. It was fractured and broken free from this one. At that point, it was trying to hold on from the wall side, and no gain of function on that one. Yeah, I had to say it. Noting the box here, this box appears non-fractured. There is, again, a fracture up here on this box, over here. Let's see, off screen a little bit. There is a fracture on this side of the box. We can find the fracture on the other side of the box. I want to load this up and share this with you because people have always asked me about this jealous wall now, so I'm start giving you the jealous wall information. The jealous wall is not finished talking. Let's see if I can find you the jealous wall is not finished revealing its little secrets. The jealous wall still has some chatter to go. There is, in that circle, you see the reinforced, the waterproofing. You see the head is the cap of that's pretty good, down to about 10, 12 inches. Looks pretty good. And then you get the rest of the fracture. Here is our wall here, our jealous wall. And there is your rotation of the backside of that box that's in there. Remember, because this box is configured, it's against the back wall with a void and spaces and all that. So when the deck went down, it had a different reaction and behavior than the rest of the deck. So you get this funkiness here, including this bent railing. The bent railing was up here on top of this wall system. No, there was one outside. So there's one outside. There's one outside here by the cars. And then there's another one up here on this rail system, which is not presenting in this image. Okay, so zooming in, we look at the tile, and you see that it just punched right through. The tile in the middle, punched right through. You don't have tiles. If you could lift the deck back up, you'd be able to put it back on top of this. Now, not to be confused, this is a layer that we're looking at. This is layered material of the overlay, along with the sand, along with the bedding and the bedding material and the tile. That's not the deck. So what matters is how did the deck behave, because these were not integral. They were not tied together with screws, etc., anchors tying, making it a composite deck. It didn't add to, it was dead weight. It didn't add to the strength behavior of the deck. So there's an overlay, sand bed, whatever it was, waterproofing sand bed tile. So that's just dead load because they never, and here's the deck below it, they never secured these two together to make it like a slab drop detail slap a panel drop where it's where it acts like a strong back, because this would have been the added material, where it made the deck stronger, the deck down below stronger, because they anchored it and made it act as one. And they would think of it as laying plywood on top of plywood, and now think of it as laying plywood on top of plywood, but this time you nail them together or screw them together. They'll behave as more like one, a composite. Without the screwing together, the anchoring, without the nails, the two sheets of plywood would behave separately from each other. So think of this as the plywood, that's sitting on top of the deck, that's just dead load. It's not helping. It's not helping to no significance. Does it help with punch shearing protection? The anchorage was not there. Could it have helped? It sure could, if they would have even anchored around each shear head and gave it a different behavior model underneath for sure, but on top also can give it a different behavior model. Being mindful that as you do those anchors, you also might be creating a shear plane. So if you had a ledger on a deck for you're going to build a deck, and you put all your bolts same place, say 6 inches apart, you're creating a crack right across your materials. Same thing with the column. If this was the column and you go working the concrete and you put down all these screws, you could be doing the same thing as this. So you got to be very mindful of how you do the attachment. And that would not be, and I'm not a fan of wedged anchors. Epoxy is much more, it becomes active once you start stressing it. But wedge anchors, they are how you break apart marble, how you break apart huge sections of granite off of a 50-foot tall piece of granite. You wedge them and you separate them, and dynamite too. But the dynamite, the force is the wedge. So I'm not a fan of wedge anchors in respect to that. Okay, let's see if I can get you one more. Trying to get out of that. Okay. This I'm saving it. I'm saving this. But we'll get to my beautiful column there and what it talks about. Okay, well, let's do this, because that's the other side that I was talking about, the fractures. So here, note how it's the slippage, how it's slid off, how the fracture is, and that's that plane we see at the very end where we see it like that, and you see the opening. I say it's about 12 inches, and there's the waterproofing, the top cap. That's in a couple images back in the video, this video right here. So you see the sliding, the fracture there. And again, we're coming back to the jealous wall, and a shear plane was created this direction and that direction. And so one hit compressive and it fractured, it cracked right there. Let's clear this all out and look at that fracture there that I was just identifying. So a shear plane can be this direction too, right? Not just going up and down. So it had something compressive or holding on to it, the wall system, for example. And at the end result, the top part of this presents as shear plane, snow and ice. How do avalanches happen? Just all one sheet of snow? No, snow happens, and then a little bit of drizzle happens, perhaps, and then it creates an ice layer. And then you get your next storm of, say, 3 feet of snow. Everything's good to go, and then let's have a little more snow to that, and we have another ice cap on top of that, and then we get another 1 foot of snow, and then it happens over a few cycles, but eventually those snow, ice, snow, ice, snow, ice. This layer, one of these layers, can no longer hold the upper layers, and all of this snow starts sliding off between one of these planes on the ice layer, and then all this it's an avalanche. But it's not just snow overloaded and then sliding down. It's the ice layers that are creating the shear planes. So you're looking at the shear planes there. There is in this one, you can see the waterproofing is here. The waterproofing's there. And this is the para. There's that trash can I talk about with the lid not even off, so it's right about where it was. There is K right there sticking up again. So I'm trying to zoom in for you. It looks like I got to hold it for you because it bounces back, springs back. See K with the little ear sticking up, and in front of it. Okay. So this had a little bit more on the other side before you met the gate. This is what? Missing. A piece of railing that should be hanging across is gone. Watch me. Watch out for me. You know how I get. A little tricky. So, alright. I'm probably going to end this video with that. I wanted to show you what was going on there against that wall, the jealous wall. I have more for you about the jealous wall. Let's see if this will help us out. More for you about the jealous wall. At least now you can understand it. Remember that this had a 19-inch hole in it. It had a configuration for planter boxes over to there. And so this behavior, along with this box here and here, and then this box is level over here pretty much like this, the shear plane about there. I pointed out to you that the behavior is going to cause your different moment over here. The box, I want to ask you this. I'm having a little fun here, if you will. The box, was it placed on top of the deck? Here's the deck. Was it placed on top of the deck? Or was it and then the tile butt up against it? Or was it or not? The tile, being crafty when I say was the tile butted up against it. So in my Columbo move there, I'm directing your attention to somewhere, but I really don't mean tile for my hint. I want you to think, let me do better than that. I want you to think in my previous videos. So it's in the previous videos where I show my hand and I start talking about a flap. That's your cue to a clue to this question I just asked here. You know I like stacking data because ultimately this is just, I would bore you guys I would bore you and it would take so long, and your brains won't be ignited as much unless I drag you into thinking. So I don't really mean tile. All right, I mean the pavers. There's that reaction there. There's this one. Now you understand that one a lot more. Now you understand the slide action. Now you understand this a lot more. This one should help you with my hand action when I showed you in the hand video 2 videos ago, or maybe 1 video ago. This we're going to get to because I'm going to teach you about, maybe somebody beat me to it now, I'm going to start teaching about flexural failures, shear failures. Are they the same? Are they the same, a flexural failure and a shear failure? Can they present as the same? Can they present as the same? Okay, let's see one more thing. Come on. What images do we have here? I'm just looking at the images. Let's grab this image. See what somebody circled. What they circle here? Column. They just circle in columns. Circling columns. Miami Beach Champlain Tower apartment collapse. What else I got here for you? Seymour butts, and Seymour. Oh, that's what it was. I wanted to talk to you about stirrups today also, but I'm going to keep it short. Think of those. I can't find the column shots. The columns where they were moving away. I'm just going to give you a quick drawing. So the columns, they transition at the 8th floor to 4 pieces of rebar. So one, we would see 2 this way. So at the top view, it would be like this. That, let's see, 1, 2, 3, 4, about like that. And around there you would have stirrups and concrete. Well, we keep finding this one here. We keep finding this where we find the rebar sticking out, and then on this side we find the same thing. We find some stubs or something like that, but we're not finding a stirrup systems. I did see one, the stirrup way down here, but in this connection I'm not finding the stirrups are continuous going across, and then your deck would tie in still. But stirrups would have made this behave a lot differently. Let's clear it. Stirrups would have made this. Oh, redraw. Let's do this. That's the full column. The stirrups. This is this without a break in it, but there is an overlap, right? There's overlapping steel, and this looks like that. And it seems like I can't find the stirrups that tie these together, which would be about every 6 inches or 4 inches then. So I don't seem to be finding these stirrups. Remember, I just don't give videos just to be giving them. I did the wood video for you about stirrups, and I was hoping someone would translate that to, oh, they should be at the branches, at the two connections. Branch A, branch B should then be stirruped pretty darn significantly. Should be stirruped together. So if this thing starts rattling, if this column starts moving, that it will behave as one. But without stirrups, and you have this and this, with some overlap, well, they're able to break free a lot more significantly easily if you get some rattling of the structure. So it appears that stirrups are not really. I didn't really see them. I looked for them. I looked under that K one. I mean, it's like they just disappeared. So what would that indicate? That there should be some stirrups around here somewhere on the ground. I've gone through this pile and I can't find these damn stirrups, a significant amount, or them interlocked right there at the failure, at the column failures. I don't seem to be finding the stirrups that should be there per the plans and per ACI 1979. All right, I'm ending the video. Take care, and hopefully that was somewhat informative for you and adding some clues and fun.